will be equal. These two impedances will be equal. So impedance matching will happen, right? So this is very simple. I forget to tell you one more formula in the previous where we derived ZIN and ZSC. Let me just check. ZSC and ZOC. Yes. So what is ZSC? ZSC is J Z not 10 beta L. Let me just rewrite here. What is ZSC? ZSC. ZSC is J Z not 10 beta L, right? What is ZOC? ZOC is J Z naught cot beta L, or you can also write J Z naught divided by 10 beta L, because 1 upon 10 beta L is equal to cot beta L. So if you multiply you multiply these two, ZSC into ZOC. If you multiply, what you will get? You will get here Z naught square, and you can write the characteristic impedance in terms of ZSC and ZOC. So you may see the question based on this formula also. Short circuit impedance will be given to you. This uh, Z naught will be given to you. You need to calculate ZOC, or you may be see that these two terms will be given to you. Calculate the characteristic impedance of the line, right? So you can calculate using this formula. It's a very simple formula. Suppose Z in SC is given to you as 100 ohm, and Z in OC is given to you 50 ohm. So Z naught, the characteristic impedance, will be nothing but equal to this 70.7 ohm, like this. So this is the way you can calculate the Z naught, characteristic impedance of any characteristic transmission line, if the Z in SC and Z naught OC is given to you, right? So if these two values are given to you, you can calculate the characteristic impedance. So now let us do the waveguide portion. Waveguide. Then, if time permits, we'll go to the Smith chart. Very important. Waveguide. Waveguide basically will do the rectangular waveguide. Rectangular waveguide. Rectangular waveguide. Rectangular waveguide is like, suppose this is X, this is Y, and this is Z, Z axis, right? Z axis. So the rectangular waveguide is like this. This is the length. Sorry, this is the, you can say, width, generally represented by A. This is represented by B, and its length is this, along Z. Along Z. This is its length, L. So a small L you can write. So the dimensions are generally represented by A cross B. X dimension by Y dimension, A cross B. Generally, A is equal to 2B. This is a standard actually. In standard, right? It is general, not always true. So you can just write the dimensions is equal to A cross B. And it is sometimes, right? A is equal to 2. If not given, you can assume. If not given. If not given. So A equal to 2B. Or you can say B equal to A by 2. So the wave is transmitted from this point. The wave will be transmitted because waveguide actually acts as a high pass filter. High pass filter. High pass filter. It will attenuate certain frequencies after if the cutoff frequency of this waveguide is FC, then if the frequency is less than fc, then it will attenuate the wave. Attenuate the wave. If it is attenuating the wave, it means there is some attenuation constant, right? Alpha. And if f is greater than fc, it can propagate through the this waveguide. It means there is some beta also. So here it is also, there is a propagation constant. But we will generally talk for alpha equal to 0. So we will write, I will write some formulas that will be very useful for calculating some characteristics of this waveguide. This first formula is the cutoff frequency. Cutoff frequency. So waveguide will be given to you, these dimensions will be given to you. You need to calculate the cutoff frequency. The cutoff frequency is given by c by 2 m upon a whole square plus n upon b whole square under root. So now you can ask that what is m and n. M and n are modes in x direction and y direction respectively, in x and y. So so in the question it will be given to you, calculate the cutoff frequency for any particular mode. Suppose TE mode. TE means transverse electric, and there is one other. Well, this is a transverse magnetic. So in the question, they may ask you, calculate the cutoff frequency of a given rectangular waveguide for TE20 mode. For TE20 mode. 2 means in the x direction there are two half number of cycles. 0 means there are no cycles in the y direction. So suppose the question is given to you. Let me just take one question. I will explain you. Suppose yes, the question is an airfield. Question is an air filled. So air is filled in the rectangular waveguide. Rectangular waveguide is given to you, whose dimensions are 3 centimeter by 2 centimeter. So A is given to you, B is given to you, and operated at a frequency of 30 gigahertz. 30 gigahertz. This is the operational frequency. This frequency. Calculate the cutoff frequency for TE20 mode. So you need to calculate the cutoff frequency for TE20 mode. So simply apply the formula. TE20 mode, M is equal to 2, N is equal to 0. So simply apply that formula. C M divided by A square plus N divided by B square. So when n is 0, this whole factor will be 0. Still, this will be equal to this C M by 2A. So FC will be equal to MC by 2A. Just put these values. M is equal to 2 and C is equal to 3 into 10 to power 8 meter per second into 2. Here the important thing is A. A is given in centimeter. A is given in centimeter. So you need to convert it into meter, because this is also in meter. This C, you have written the value in C in terms of meter. So you need to write this in terms of meter also. So 3 into 10 to power minus 2 meter. So if you solve this, you will get 10 to power 10. It is nothing but equal to 10 to power 9, or you can say 10 gigahertz. So in the option you may see the other option also. If you ignore this, you will get something like 10 to power if you in case if you ignore this factor, if you ignore this factor, right, if you ignore this factor, here you will get 10 to power 8, 10 to power 8, right, 10 to power 8 hertz, right, if you ignore this factor. So in the answers there will be definitely this 10 to power 8 is nothing but equal to 10 100 megahertz. So in the answers you may get this option definitely. So you need to check whether the A is given in terms of meter or in terms of 1000 megahertz. D is equal to 10,000 megahertz. So based on this you can calculate, right? What is the correct answer? So the correct answer is option D, 10,000 megahertz, because giga is 10 to power 9 is equal to 1000 10 to power 6, right? 10 to power 6. So it is equal to 10,000 megahertz. Mega is 1 mega is equal to 10 to power 6. 1 giga is equal to 10 to power 9. So based on this, the correct answer is D, right? 10,000 megahertz or 10 gigahertz or 10 gigahertz, right? So this way. So this is about the cutoff frequency, right? We have calculated the cutoff frequency. For the same question, they may ask you calculate the impedance of this impedance. There is a similar to that transmission line, electromagnetic theory. There is impedance of a waveguide also. The formula for this is eta upon cos theta, and for Tm mod it is equal to eta into cos theta. Now we will see what is cos theta. Cos theta is nothing but equal to one factor, that is equal to 1 minus fc upon f whole square. So for propagation fc should always be less than f for propagation, because if fc is greater than f, this factor will become imaginary, right? Fc should always be less than f. Fc should always be less than f. Then it will be able to propagate. The wave will be able to propagate, right? So in the above question, Fc is give Fc we have calculated this 10 gigahertz. We have calculated, right? We have calculated this 10 gigahertz. So what will be the value of cos theta? Cos theta will be equal to 1 minus what is fc, 10 gigahertz, divided by what is f. F is frequency of operation. A frequency of operation, operational frequency is given, operational frequency is given 30 gigahertz, right? 30 gigahertz. So the wave is propagating at 30 gigahertz, 30 gigahertz square. And if you solve this, you will get cos theta will be equal to 2 root 2 divided by 3. 2 root 2 divided by 3. So if you now calculate eta te, this is eta is eta naught, actually eta naught we have already studied. Eta naught is equal to 120 pi or 377 ohm. It is same value. So eta t is nothing but 120 pi divided by 2 root 2 divided by 3. It will always be greater than 120 pi, because cos theta is always less than or equal to 1, right? Always less than equal to 1. So this will be approximately equal to 400 ohm. So this will always be greater than eta. This will always be less than eta naught or equal to. It depends on theta, right? So this is the eta. The next is phase velocity. Phase velocity. Phase velocity. There is one term that is known as a phase velocity. Its value is c upon cos theta. C upon cos theta. And there is another term, group velocity. Group velocity. And it is denoted by Vg. Its value is c into cos theta. C into cos theta. And if you multiply these two quantities, Vp into Vg, you will get c square, right? Then the speed of light will be given by this. Vp will always be greater than c or equal to, and it will be always be less than equal to c. So if the question is same, and if I ask you what is the phase velocity, then the phase velocity will be equal to, phase velocity will be equal to 3 into 10 to power 8 divided by 2 root 2 divided by 3. So you can calculate this. Similarly, if I ask you what is group velocity is equal to 3 into 10 to power 8 into 2 root 2 divided by 3. So you can calculate this. So this is a formula for group velocity and the phase velocity, right? This is all. So there is one another term, that is a guided wavelength. Guided wavelength. I'm just telling you the important formulas on based on that you may see the questions. Guided wavelength denoted by lambda g, lambda g, and this formula is like this: 1 upon lambda naught square minus 1 upon lambda c square is equal to 1 upon lambda g square, where lambda g is guided wavelength, lambda c is cutoff wavelength, lambda naught is operating wavelength. So we will calculate all these three values. Lambda naught, because we know how it is related to C and F. We know C is nothing. C is speed of light. Any velocity actually is given by, any velocity is given by lambda into F, right? So operating wavelength is given to you. You can calculate. Sorry, frequency is given to you, 30 gigahertz. You can calculate this operating wavelength. So how to calculate the operating wavelength? V is given to you, that is C divided by F naught. From here you can calculate lambda naught, right? Lambda c you can calculate C divided by lambda c is given as, so speed, oh sorry, here it will be speed, or speed you can write just simply a V upon, here it will come cutoff frequency. So from here you can calculate the value of lambda g, this formula. This is a formula to calculate. These values are given to you. These values are given to you, right? Suppose this frequency is given to you as a 30 gigahertz, then you can calculate this is C, 10 to power 8 divided by F naught is 3 into 10 to power 9. Right? 30 gigahertz, 30 into 10 to power 9. So based on that, you can calculate the value of lambda naught. Similarly, you can calculate the value of lambda c just by putting the value of fc. Once you put this, then you can calculate the value of lambda g, because you have all the values. You have lambda naught, you have lambda c. So these are some of the uh, formulas in the waveguide. And because waveguide is acting as a high pass filter, so if the question is whether a wave which is operating at 5 gigahertz will propagate through the waveguide or not. If the question is like this, first if the question is whether the wave operating at 5 gigahertz will be propagating through the waveguide or not, it will depend on the cutoff frequency. So first task is to calculate the cutoff frequency. Once you calculate the cutoff frequency, then you need to check whether the operating wavelength is less than the cutoff frequency or it is greater than that. If it is greater than that, then it will propagate. If it is less than that, then it will not propagate, it will attenuate. So you can say this wavelength will this wave will not be propagating through this waveguide, because the cutoff frequency is higher than the operating frequency, right? Waveguide always act as a high pass filter. It will only pass the frequencies which are greater than the cutoff frequencies. So this is the basic funda behind the waveguide, right? And there are some one mark question that you can remember: the dominant mode. What is the dominant mode? Dominant mode. Dominant mode is the uh, in a waveguide. The dominant mode, for dominant mode, the cutoff frequency will be lowest. For that mode, we will see the mode which is having the lowest cutoff frequency. The mode which is having the lowest cutoff frequency. Lowest cutoff frequency. Lowest cutoff frequency. FC. Lowest. So what is the formula for FC? FC formula is C by 2 m by a whole square plus n by b whole square, right? This is the formula. So what should be the lowest value of this? Lowest value should be for m is equal to 0, n is equal to 0. It means fc is equal to 0. But this is not the lowest value, because when m is 0, n is 0, then it means the wave, there is no mode, wave is not propagating. So in rectangular waveguide, this is not the lowest mode. The lowest mode is m is equal to 1, n is equal to 0. So when m is equal to 1, m is equal to 0, TE10. You may ask, why not TM10? Because TM10 will not exist. T M TM in general, m or n can not be equal to 0. These two values cannot be equal to 0 in TMN, but in TEMN, these values can be 0. These values can be 0, but not both. Any of these two values can be 0. So TE10 mode has a cutoff frequency is equal to MC upon 2A. And if you calculate the cutoff frequency for 01 mode, then the cutoff frequency will be n m is equal to 1 here, right? It will become c by 2a, c by 2a, c by 2a. So here it will become c upon 2b, c upon 2b, because a is, in general, a is greater than b, a is greater than b. So this is the lowest value, this is the lowest value compared to this, right? So TE10 mod is dominant mod. Dominant mode. So this, sometimes you may see the question like this. And these modes which are not existing, these modes, these mode these modes are known as the modes which do not exist in the rectangular waveguide is known as evanescent mode. Evanescent mode which do not exist, these are known as evanescent modes, and this is known as dominant mode. TE10 mode is the dominant mode. There is one another mode, that is degenerate mode. Degenerate mode. Degenerate modes. Degenerate modes are those modes which have the same cutoff frequency. Which have the same cutoff frequency. So for all the modes which have the same cutoff frequency, TMN or TMN, if M or N are equal, right? If M are all the modes which have the same cutoff frequency can be, I will just give some example. Same cutoff frequency like TE11 and TM11. These both have the same cutoff frequency, because the cutoff frequency formula is this, right? It is not depending on whether it is TE or TM. It is not depending on TE or TM, right? So it is only depending on M and N. M and N. So if these two values are equal, then we can say these are degenerate modes, like TE32 or TM32. These two modes are also degenerate modes, right? These two modes are also degenerate modes because the cutoff frequency is same. So this is all about the waveguide and the related terms that we discussed, right? So now we'll discuss a little bit about the Smith chart. Smith chart is very important in Smith chart. You may see one question on this Smith chart. Smith chart is actually a representation, a graphical representation of transmission line values. Everything is whatever we have studied in the transmission line. Now we will study this in graphical form. Graphical form. So any impedance, this suppose any impedance which is ZL, any value, suppose R plus JX, right? Any value. This is given to you. We will represent this impedance in terms of graphical form. Graphical form. So first, what we will do, we will normalize this impedance with respect to Z naught. Normalize this. Divide by Z naught. Divide by Z naught. Divide by Z naught. Suppose divided after division, suppose we can take actually a small one, instead of, we can take small value r x, then it will become zl, it will become r plus jx, r plus jx, right? Where capital R is normalized impedance, normalized resistance, normalized resistance. Similarly, X, capital X is normalized admittance. This reactance, this is reactance, normalized reactance, right? So now we will represent in terms of graphical form, like what is gamma? Gamma is nothing but equal to ZL minus Z naught, ZL plus Z naught, right? It is ZL minus Z naught divided by ZL plus Z naught. Because ZL is, what is ZL? ZL is complex. This is a complex value. We have assumed a complex value. So if it is complex, this gamma will also be complex. If gamma is complex, we can write gamma R and gamma I. This is the real part, this is the imaginary part. Now put the value, put this value of ZL, R plus JX minus, sorry, this will also be normalized, because what is, if you put here ZL, then you need to normalize it, right? You need to normalize it, right? So now put this, this is nothing but ZL upon Z naught, right? Normalized value. You put this value, if you put this value here, it will be 1. So gamma will be equal to this, right? Gamma will be equal to this. Or you can say gamma is equal to gamma R plus gamma I equal to R minus 1 plus jx, R plus 1 plus jx, right? So this is a gamma R and gamma I. So this is a complex quantity, right hand side. So we can separate these two terms, right? We can separate these two terms. So just this decompose these two into real part and the imaginary part. So separate out the real part and the imaginary part. So if you separate out the real part and the imaginary part, you will get two equations. You will get two equation. Gamma R minus R plus 1 whole square is equal to, sorry, it is not equal to, plus gamma I square is equal to 1 upon R plus 1 whole square. And the second equation, because there are two equations, because if you separate out the real part and the imaginary part, you will get two equation. First will be this equation, the second equation will be gamma R minus gamma R minus 1 square plus gamma I minus 1 upon x whole square equal to 1 upon x whole square. right? So there are two equation. Equation number one, this is if you see here, it is variable is only r, capital R, right? Capital R. Here if you see, the variable is x, right? So this first equation is known as constant. This is an equation of a circle, right? This is an equation of a circle. X minus a whole square, y minus b whole square is equal to r square, right? Where x is gamma r, where y is gamma I, right? This is like that. You can actually write capital R also. That's just, and R is equal to 1 upon R plus 1, and A is equal to R upon R plus 1. B is equal to 0, right? So what is the center? This is known as constant R circle. This is known as constant R circle. Constant R circle equation. So I will tell you the questions also based on this. This is known as constant X circle. Constant X circle. The center of the constant R circle is R upon R plus 1 comma 0, and the radius is R plus 1. The constant x circles, the center is 1 comma 1 by x, and the radius is 1 by x, right? 1 by x. So now we have a constant r circles and we have a constant x circles. Now we will plot these two circles. We will plot these two circles. Let me just plot these two circles. Yes. So now I will plot these two circles. The first circle is gamma R circle. First, I will plot R circles, gamma R circles, and the radius of these is R plus 1, comma 0, and radius is 1 upon R plus 1. And then I will plot gamma X circles, gamma X circle. Oh, sorry, imaginary, real part and imaginary part. Gamma I, and the this radius of this is 1 comma 1 by x, and 1 upon x. This is the center, this is the radius. So suppose now I will plot this. I am taking one line. This is gamma r, this is gamma I. I am assuming this is gamma r, this is gamma I, gamma r line and gamma x line. Real line, this is imaginary, right? This is imaginary. So if r is equal, here the r is 0, right? R is 0. So first we will plot r is equal to 0. If r is equal to 0, then the center for these circles will become 0 comma 0, right? Center will become 0 comma 0. And what will be the radius? Radius will become 1 upon 0 plus 1. So the center for r is equal to 0. For r equal to 0, center will become 0 comma 0, and radius will be 1. So there will be one circle. There will be one circle. There will be one circle. You will get one circle, right? You will get one circle. This is r is equal to one circle, right? R is equal to, sorry, 0. R is equal to 0 circle. Now we will plot r is equal to one circle. R is equal to 1. R is equal to one circle. If put r is equal to 1, if you put r is equal to 1, the radius will center will become 1 by 2 comma 0, and the radius will become 1 by 2. So 1 by 2 will be here, because this is 1, this is 0, right? So this will be somewhere 1 by 2, right? So the center is this, the center is this, and the radius is 1 by 2. So if you plot, circle will be looking like this circle. like this, right? So if you plot, you will see the circle will be looking like this. It's not a proper circle anyway. Let me just draw it like this, right? So this circle is R is equal to one circle. Now plot R is equal to two circle. R is equal to two circle. R is equal to two circle. If you take R is equal to 2, what will happen? It will become 1 by 3 comma 0 and radius will be 1 by 3. 1 by 3 will be at somewhere here, right? Sorry, it will be 2 by 3. It will be 2 by 3. 2 by 3 will be somewhere here 67.67 at this point. And the radius, how much radius? Radius is 1 by 3. So this distance is 1 by 3. So you will see a circle. You will see a circle. You will see a circle. This is 2 by 3. You will see a circle like this, right? You will see a circle like this. So this circle will be R is equal to 2 circle. Similarly, you can plot for R is equal to 5. If you plot for R is equal to 5, you will see like this. If you plot for R is equal to 10, you will like this. If you plot for R infinity, because R is a resistance. Resistance can vary from 0 to infinity. So if you put infinity, what you will get? This will become 1. So center will be 1 comma 0 and radius will be 0. So you will get a point here. You will get a point here. So this will be R infinity circle. R infinity circle. So these are known as constant R circles. Constant R circles. Next we will plot constant X circles. Constant X circles. So first we will take, so all the circles having the radius at this point, a center at this line. All the radius, all the circles having a center on real axis, right? Center on real axis, and all the circles are passing through a one point, that is common point 1 comma 0. All the circles are passing at one particular point, that is 1 comma 0. So this is the property of a constant R circle. Next is constant X circle. So now we will plot X is equal to 0 circle. First we will assume X is equal to 0. If X is equal to 0, then it will be like this: 1 comma infinity comma infinity. So this is nothing but a straight line. This is a line, straight line, right? 1 comma infinity will lie somewhere here, and this line is nothing but, x is equal to x is equal to 0. This line is nothing but x is equal to 0. So similarly you can plot for x is equal to 1. X is equal to 1. If you plot for x is equal to 1, radius will be 1, center will be 1, 1 comma 1 comma 1. So what is the center? Center is at this line. Center is lying at this line. This is 1, this is also 1. So center is this 1 comma 1. And what is the radius? Radius is also 1. So this circle, this circle, this circle, if you plot the entire circle, I will not plot the entire circle because r is this is the maximum limit of the Smith chart, because r is always a positive quantity, right? So we will not go outside of this circle, bigger circle. So we'll only plot for the inside. So this is r is equal to, sorry, x is equal to 1. Similarly, you can plot for x is equal to 2. X is equal to 2. If you plot for x is equal to 2, 1 comma 1 by 2 and 1 by 2 is the radius. 1 by 1 by 2 will be here, right? 1 by 1 by 2 will be here. 1 comma 1 by 2. 1 by 2 will be here, and the radius is also 1 by 2, right? 1 by 2, this much radius. So if you plot, you will see like this. Sorry, yeah. So you will see like this. It will go here like this. So this will be like this, but we will not plot outside we will not plot, we will only plot up to this point, right? So this is x is equal to 2. Similarly you can put for other values also. Similarly you can put for other values also. So x is equal to 5, x is equal to 2, x is equal to 1 by 2, x is equal to 0.5, x is equal to this may be x is equal to zero point 0.5, right? So this may be equal to x is equal to zero point 0.1, like that. So in this way it will be like this 1.1 zero point 0.2, like that, right? So in this way, similarly we can plot for x is equal to -1, because x is inductive, it can be capacitive also, right? If it is capacitic, then we need to take the value of minus, right? If you take the values negative, then what will happen, it will go down like this. So this will be x is equal to minus zero point 0.1. This is x is equal to minus zero point 0.5. This is equal to x is equal to minus 1. This is equal to x is equal to minus 1 by 2, like that. Sorry, minus 2, and so on, right? So this is the Smith chart. This is the Smith chart. So we have the circles. I will just show you some questions how to calculate the impedance from this circle. Suppose we have given this this plot. So generally the Smith chart is given like this, very simple way, with one biggest circle. One this circle will be given to you, and this x circle will be given to you. This x circle will be given to you, like that. So whenever this will meet, this is x equal to 1, this is x equal to -1, this is r is equal to 0, this is r is equal to 1, right? So what is this point? What is this point? If I ask you what is the impedance at this point? What is the impedance at this point? What is the impedance? Impedance is given by R plus jx. What is impedance? Suppose this point is A. At A, what is R? R is equal to 1 circle. So R
One.
is 1 plus J. What is X? X at this point. This is X. This is X. X is equal to 0. So this is equal to 1 plus J 0 into, you need to multiply it with the normalized impedance now, because it is normalized. So you need to multiply with Z naught. So the answer is Z naught. So the impedance at the center of a Smith chart is Z naught, right? So it's the same way. If I ask you what is the impedance at this point, suppose this point is B. What is the impedance at this point? What is the value of R at B? What is the value of R at B? The value of
Zero.
R is, what is this value? 0. 0.
Yes, sir.
What is the value of X at this point? 0. So what is the impedance? The impedance is 0 plus j 0. So this is a zero impedance, 0 ohm, or you can say short circuited. This is the short circuited. So if I ask you what is the impedance at this point, point C, yes, you calculate. Please type your answer in the chat box. What is the impedance at point C? I am giving you the four options. Impedance at point C. The option one is J. The option one is J Z naught. B. The option B is Z naught. C 0. D Z naught plus J Z naught. So which one is the correct answer? Please type in the chat box. At point C, at point C, what is the value of R? At point C, what is the value of R? R is equal to what? What? R is equal to what? And also calculate the value of X. Then once you calculate R and X, then you just need to multiply it with Z naught for calculating the total impedance. Because initially we assumed normalized impedance, right? We assumed normalized impedance. We multiplied initially by Z naught, right? We multiplied initially by Z naught when we were deriving, right? When we were deriving, we multiplied. So what will be the answer? Please type in the chat box. 0. Someone is typed 0. R is 0. Yes, at point C, R is 0. But what is
Sir,
X?
sir, can you repeat once due to some
What
network issue?
is the impedance at point C?
Hello?
Yes, yes, yes. What is the impedance at point C? What is the impedance at point C? The options are this. These four options are given. This is very important. You may see this type of question, 1 mark question, and very simple. You just need just 5 to 10 seconds. You just need to think, nothing else. First you need to calculate the value of R, then you need to calculate the value of X, and then you need to multiply it with Z naught, nothing else. And even if Z naught is not given,
J zero.
you can directly write. If Z naught is not given, the options may be like this also. The option may be like this also. You should not confused with the options. You may get the options like this. So what is
Sir,
the
answer
answer?
B. Answer
Yes,
B
but
is 1.
answer D. Someone said answer D. All of you,
Sir,
please
B.
calculate. Priyanka,
B, sir.
Priyanka typed
B.
answer B, option B. So the correct option is option A. Why? Option A is correct because what is the value of R at this point? R at this point is equal to 0, right? R at this point is equal to 0. What is X at this point? This circle. This circle is X circle. So X is equal to 1. X is equal to 1. So impedance is equal to R plus JX. 0, 0 plus J1. So J1 means this answer. This is the correct answer. Let me ask you another question. Calculate, calculate the impedance at this point. Point E. This point. Calculate the impedance at this point. Point E. At point E. Calculate the impedance. The options are A, J, B 0, C 1 plus J, D 1 minus J. What is the correct answer? Type in the chat box. You just need to calculate the value of R and X, nothing else. Just check which circles are intersecting at that particular point. You just need to see. You just need to see first R circle, then you need to see the X circle, nothing else. So this circle is what circle? R is equal to X circle. This is a R is equal to X, R equal to 1 circle. So R is 1. R is 1 at point E. R is 1. What is the value of X? X is this circle, right? This circle is also X is equal to 1 circle. So X is also equal to 1. So what is Z? Z is equal to 1 plus J1. So the correct answer is C. The correct answer is C, right? So I will ask some Priyanka typed C, Kunal typed C. So good. So Ankita typed D. Why D? Let me ask you another question. Uh, Calculate at this point. Calculate at this point. The point, this point. Suppose this point is F. F. Calculate the impedance at F. Calculate the impedance at F. Calculate the impedance at F. And the same options are given. Suppose the same options are given. Calculate the impedance at X. Sorry, F. F. This point. This point. Calculate the impedance at this point. Type your answer. Kunal typed D. Answer D. Yes, answer is D. Right. Because the two circles, R circle and X circles, are intersecting at this point. X is equal to -1 and R is equal to 1. So if R is equal to 1 means this R is equal to 1 and X is equal to -1. It will be multiplied by J. So it will become 1 minus J1. So the answer is D for F point. This is for E point. So I will ask you another question. Uh, Suppose this is the constant X circle, R circles. Constant R circles are given like this, right? And constant X circles are given like this. Sorry, like this, right? So tell me the value of a point, this point, this point. Suppose this point is A. Options are options are calculate Z at this point. Options are 0, 1 plus J minus J. Calculate, or you may see the options like this: Z naught, Z naught, Z naught. It is just multiplying with some characteristic impedance that we are. If the characteristic impedance is not given, you can assume 1. If it is given, then you need to multiply at the end, right? So the options are these. What is the correct answer? What is the correct answer? So type in the chat box. So Kunal typed answer D. Ankita typed answer D. Anyone else? So all of them are typing. Priyanka also typed answer D. So the answer D is the correct answer. Why? Because at this point, two circles which are intersecting is this. One circle is this, which is R is equal to 0 circle, right? R is equal to 0 circle, and one circle is this. One circle is this black circle, that is X is equal to 1 circle. So it is equal to 0. Sorry, minus 1 circle. 0 minus 1 J. 0 minus 1 J. So the answer is D. 0 minus J 1. You need to multiply it with Z naught. So you can write minus J Z naught. Right? Okay. Now let me ask you, suppose this circle is X is equal to 1 by 2. Then calculate point number B. Point number B. Calculate point number B. The impedance at point number B. Options are A is equal to options are option A, option A, option A is Z naught, option B J Z naught, option C Z naught plus J Z naught, option D Z naught plus J Z naught by 2. Okay, so which answer is correct? Arshia answer D, Ankita answer D, Kunal answer D. So now you know how to calculate the impedance using the Smith chart, right? You know the how to calculate the Smith this impedance using the Smith chart, right? So this is all about the Smith chart. You can check the value of any so we have this gamma equal to these values, like this is the let me just correct value, this is the correct. So what is R plus jx? R is, we know the value, x we know the value, right? We can calculate. So you can also calculate the other things like VSWR from this Smith chart also, that we need to actually go into detail. But for simplification, I'm just telling you, these are the constant R circles, these are the constant X circles. So if you have any doubts in today's lecture, you can ask now. The time is actually over, so this is much I can cover.
Sir,
Yes,
I have a doubt in transmission line.
yes. Which what is the doubt?
Sir, question.
Let me just show you. Just tell me the doubt. Which question?
Yes, sir.
This one.
Yes, sir. How
What
was
is
the
the
answer?
doubt? Yes.
Sir,
What is your doubt?
sir, how was the answer is D?
How is the answer is B? No, no, no. Answer here it is D. Answer is D. Option D.
Yes, sir. How?
Okay, okay. So is this first one is correct? Is this okay? The first portion B means this transmission line is matched with this. Is that okay? See, the input impedance of a short circuited transmission line is given by this formula. Is given by this formula. And what is the length? Length is given by less than lambda by 4. If the length is less than lambda by 4 means electrical length will be less than pi by 2. Pi by 2, right? If the electrical length is less than pi by 2 means it is in the first quadrant. Theta is less than pi by 2. It means it is in the first quadrant. In the first quadrant, 10 is always positive. Tangent of any angle in the first quadrant is positive. So this quantity is positive. This quantity is positive. And what you will get? J Z naught. This is also positive. So you will get positive value. So you will get J Z naught or any constant a. So it is a inductive part, j omega l, like that type of part, right? In this it is an inductive means this can be replaced by an inductor which whose value is l, that we can calculate, right? Is this correct? Any doubt in this?
No, sir.
Okay, so comes to the second part. Here the open circuited line is given. Open circuited line. The impedance formula is minus j z naught cot beta L. But here the L is lambda by 2 to lambda by 4. Lambda by 2 to lambda by 4 means the beta will be this. Beta will be this. If beta is between pi to pi by 2, it means in the second quadrant. If it is in the second quadrant, the 10 will be negative. Quote will be negative in the second quadrant. So if it is a negative, so negative is this quantity is negative, and there is one minus sign also there. So minus into minus plus, right? So Z in will be some plus value Z naught and some constant B, right? So this is also plus. Plus means inductance. So it is an inductance, right? So this is also replaced by an inductance. Is this okay?
Yes, I got it.
Okay. So any other doubt?
No, sir. Thank you.
Okay, 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 okay. So I will share the previous notes and today's notes with the madam, so that she can distribute in your class. So in case of any doubts, you can also email me. My email ID is given at NIT Tirchi website, so you can see that, and you can ask me the question at any time.
Okay,
Hello,
sir. Thank
Snehal
you.
ma'am. Yes, yes,
Yes, sir.
thank you. Yes, ma'am. So from my
Yes.
side, it's done.
Okay,
So
sir.
yes, ma'am.
Sir, on the behalf of Electronics and Communication Engineering Department of college, I would like to thank you for taking session of Git and sharing your knowledge with our students. And I will circulate the notes that will be provided by you to the students, sir.
Yes, ma'am. I will share the notes with you, and
Sure,
thank you
sir.
for inviting me.
Yes, sir.
Thank you, ma'am. Yeah.
Thank you, sir.
Okay.
Thank you.